Thank you, Nikos. So, good afternoon, everyone. So today, presenters made a presentation about advanced robotics and its theory, and Professor Long made a presentation, very serious, very important issue. So I decided to present today. My presentation will become you more comfortable. So I believe that the thinking robot is a pleasure and fun. So I want to ask you to enjoy my presentation. So the title is Karakuri. Do you know the word Karakuri? No, it's a Japanese word. So Karakuri, here. Karakuri, there are several meanings. So originally, the mechanized puppet or automation, automaton in Japan. But it includes another meaning, mechanism and innovative device and gadget, contrivance. There are so many meanings. But I believe that Karakuri is one of the concepts of the origin of the robot. So today, I introduce the history of Karakuri to robot, and I'll introduce a history, imagination, mechanism design, computer, and philosophy, and robot. So thinking history, to know the history, is very important to make innovation or creation of the future technology. No one can create anything if we do not know the history. So then today I introduce a history of the robot. So first is Greek mythology, about 900 BC. You know the Iliad? No? So there is it's an imagination, of course. There is two important robots there. One is automaton, and the other is Taros. Taros is a giant man of bronze who protected Europe in Crete from pirates and invaders by circling the island's shores 3 times daily while guarding it. So there is some picture from the motion pictures. It's a Taros. It's very giant man. But there is very interesting topics. So finally, Taros killed by the enemy because there is a hole, some hole of the foot of the Taros. And enemy put off that such tools, then all the liquid inside the Taros flow out. Then Taros killed. It contains very important meaning because that liquid means blood. So the people in the ancient Greek consider what is a human mechanism? What is a human? That is a big question. So they make a story about the Taros. It represents some mechanism of the human. Also, the automaton, it's a work for his assistants. There is an important second meaning. That is, that imagination of the robot is a helper or assistant of the human. We want to ask the robot to help us. So there is 2 meanings. That concept is now we consider at present. So many robotic researchers consider what is human, and also what is a useful tool make the robot. So already Greek mythology represent that two meanings, okay? And this is a real mechanism in also the ancient Greek inventor and mathematician is Ctesibios in Alexandria, protected Egypt. He developed several machines. One is a hydrolysis, a water organ, and the other is a clock, water clock. So at that time, there is no power source. There is no battery, anything. So he used the gravity, using the water. So, but the mechanism is almost same as we used to now as a pipe organ something. And this is a clock. You can see there is a time, and this door denotes that's a time, and there is some mechanism using a water, and it makes the people when, what time is it now? So next, Heron, also 10 AD, an ancient Greek mathematician and engineer who was a resident also at Alexandria, Egypt. He developed big two machines. One is temple door opening mechanism. The other is a steam engine. So probably this is a first steam engine. You know that probably the what he developed the very famous steam engines. But this is only the 10 AD. He already developed the steam engine. This is almost same that present we use the steam as the steam engines. There is a fire and water, and it's some spread to the steam. Also, this temple door opening mechanism using the fire. The fire, and there is air, so air pushes the water, and water run into this bucket and open the door. If the fire is out, then back to shut the door. Probably this is the first automatic door in the history. Already 10 AD, these machines were developed. So this is in China, Southpointing court. It's also made only by mechanism. You can see it's a kind of differential gear. So differential gear, it's 800 years before the first navigational use of a magnetic compass. They don't use a magnetic compass. Only use a differential gear. They realize a Southpointing cut. Of course, we have to set the first initialization to make this door to point the south. But after that, so measure the differences of the rotation of the wheels. It makes possible to keep the point to south. Now it's a year is skipped to 18th. So Jacques de Beaucasson. Beaucasson is very famous for Karakuri mechanism. You know the Beaucasson? This is a real Beaucasson's digestive duct. So for an investor and artist with a mechanical background who is credited with creating the world's first two robots, as well as for creating the first completely automated loan. This is a digest duct. So the mechanism is like this. The mechanical duct appears to have the ability to eat kernels of grain and to metabolize and defecate them. Whereas the duck did not actually have the ability to do this. The food was collected in a container and pre-stored face was produced from a second, so that no actual digestion took place. Bokanson hoped that a truly digesting automation could one day be designed. So it's a simulation. But if we observe the result of the motion of the digesting duck, the people believe that digesting duck had really digesting, because that's only the result of the observation. If people does not know the contents or the mechanism inside of the duck, the people believe that, oh, it is alive, it is digesting. It's a very important point that observation is a result, what we believe, what we can see, okay? So next, this Jacques Doros. It's a very famous automata designer, Swiss-born watchmaker who designed and built animated doors or automata. The writer, the musician, and the draughtsman. It's 76-8 to 70-74. So this is pictures. I will show you. I prepared the movies. Oh, before that, I have to explain about that mechanism. Of course, this automata does not have actuator, battery, anything. Only the mechanism of that cam. You know the cam, programmed by mechanism. So this mechanism is very important. At that stage, so there is no computers. So designer use a cam as a program. So I will show you the real movie of that Karakuri. You can see these doors at the Neuchâtel, Switzerland. So you can see that the motion of the door is very similar to human. So the designer tried to design these kind of automata resemble to human. Not only in the shape, but also the motion. You can see there is a little bit motion of the breast, because that's, she's very nervous to play organ. This is a motion of the writer. So probably there is a robot researcher here. So I want to ask you you can design such kind of mechanism? It is very difficult. But at that time, there is no computer, no programming, no battery, no actuator. But they realize that very sophisticated and dexterous motion, only using by mechanism. So I want to say that we should not forget that origin of the mechanism is very important for future robot. Yeah, probably using the PC and actuators and sensors, it is easy to realize such kind of motion. So recently, the young people want to design a robot using a PC and motors, actuators and batteries and sensors. So we should not forget that mechanism. That is, I want to say, today's presentations. So also now the single bird is a typical example of the mechanism, like automata. It's a replica made by Rouge, a company in Switzerland. Now, at present, you can buy that. So please imagine what is the inside, what is the mechanism of a singing bird. You can design that? Okay, I will show you the mechanism. It's a skeleton. You can see there is some air pump, and there is a cylinder, and it's a variable of the effective length using the cam. Cam is here, and there's a mechanism to connect to the bird. So then it changes the sound and the motion by the cam. It's very small size, only 10 centimeter and 15 centimeter and 5 centimeter. It's very small. It's a kind of cigarette case size. Okay. So this is a karakuri in Japanese, in Japan. The Kikouzue Mechanical Design is a very famous book written in 1796. I will show also the video. It's bringing the tea door. So there is a guest, then the host prepare the tea. It's a kind of tea ceremony. So then this door bring the tea to the guest. Or first says so the host puts the tea, then the door approach to the guest. And the guest took the tea, then stopped and drink, and back to the tea, then return to the host. It's also programmed by only the cam. Okay, so how do you feel these mechanisms? So people in 16th, they consider that what is the difference, human and robot? That those of automata make some discussion. What is the difference, human and robot? So the Descartes, he's very famous in the 16th so philosophical statement, cogito ergo sum. You know the cogito ergo sum? So in the lecture in my school, I asked the students, how do you show that you are a human? How to show you are a real human? That is a question. I believe the human is a robot because we cannot identify, we cannot say anything about the differences between human and robot. Probably you also cannot approve or show that you are the human or that your friend is human. So Descartes cannot answer that question. Then he said, cogito ergo sum. On the other hand, Lametri wrote a book, Man and Machine. In that book, he said human being was a machine. The interesting is that Lametri showed this digesting duck. There is a book he wrote about that digesting duck of the Vaucanson. So he believed that human is also a machine. So that is the start point of the discussion. What is the difference between human and robot? Okay, that is also important thing I want to consider. I want you to think about that. After that, this is an imagination of the Adam. Because the Adam is the Eve future, the future Eve, the android. There is a first for popularizing the term android. That is the first book using the android. The interesting that this android developed by Edison in this book. Okay, so after that, this is the first time to use the word robot, R-U-R. This is a very famous book, so then most of you read this book already. But if there are some people who did not read this book, please read R-U-R. That is the origin of the robot. And this is the imagination to real. 1945, remote manipulator developed. It's Argonne National Laboratory. And just after that, ENIAC was developed. So we consider that the history also about computers. So the vacuum tube, 94, and ABC computer is the first computer. This is 1942, and ENIAC 1943, 1946, and transistor and NC machine tool was developed by MIT in 1952. Okay, speed up. So also at that stage, the imagination is also new imagination is showed in the iRobot, like iRobot and Astro Boy. So I will show you some history about the real robot and imagination. This relation is very interesting. So vacuum tube 1904, RUR 1920, and Turing machine, ABC computer, remote manipulator, ENIAC, and transistor 1948, and iRobot, Isaac Asimov, it's 1950. Astro Boy, Tezuka Osamu, 1952, and NC machine, that's the same year. And first patent developed by George Devore in 1954, and Unimator version, and Imagination, the Space Odyssey 201 by Stanley Kubrick, 1968. And in my university, Waseda University, developed Babot 1, 1973, and Intel Corporation developed the 8-bit microcomputer 8080, 1974. And Star Wars, that is the first Star Wars, was opened 1977. That means we should we should watch the movies, science fiction. Science fiction is very important to show that the history of the imagination, between imagination and real machine, real robot. So probably, even if the science fiction, but they know that's a real technology, then they can show that imagination world. Okay, it's a time, so this is Robot 1, 1973. My mentor, Professor Ichiro Kato, developed in Waseda University. The interesting that ballet train Shinkansen developed in Japan, it's 1964, and also Apollo 11 program landing and man on the moon in 1969. So 1973 is after that, those big two development. So that means developing the robot, research on the robot is very, very difficult. So I don't have so much time, so I skip that. Skip. So now the recent, it's already 10 years ago, but probably it's now sophisticated robot about the human symbiotic robot. So I introduced some mechanism to this robot. Not only the artificial intelligence, but the sophisticated mechanism is very important to realize such kind of robot motion behaviors. So for example, that's kind of adapting human motion. I introduced some mechanical spring to the joint. That means not the force control by sensors and actuators, only controlled by the spring setting. Also next, there is a manipulation of the very dexterous manipulations by fingers. Also, I introduced some sophisticated mechanism as a fingertip. This robot has nail and also the very soft skin of the fingertip. And there is a very similar curve of the humans. So not introduce the sensor control and actuator control. That only using the softness of fingertip. Yeah, of course, there are so many sensors as a fingertip, but if the robot do not use such sensors, it is possible to handle such things. So the last, I have a quiz. Design a spherical mobile robot. Move everywhere in a room. Do not stop at the corner. Avoid obstacles. How do you design? So one solution is commercially available. It's Amazon. It's a $250 Australian. Its name is Sphero. Probably some of you know that toy. So it's actuators and sensors and very sophisticated mechanism and the battery charger and the wheels. However, there is another solution. This is also the ball. So move around everywhere in the room and not stop in the corner. Please imagine inside of this ball. What kind of sensors, what kind of actuators this ball has. This is a solution. You can see only one motor and one battery. You can see there is not in the center of the axis. Axis is not in the center. So there are only one motor and one battery inside. Battery is not installed in the center. That centrifugal force makes free mobility. And it's about $8 Australian. So that is what I want to say, that mechanism is very important. And we should learn from the history of the development of Karakuri and Automata, that mechanism. Then, based on that experience or knowledge, then we can create further sophisticated robot in the future. That is my conclusion. Thank you very much. So that.
Time for one question.
Or the now time break.
We'll have 10 minutes.
Then during that I can.
So human as a species, we have the inkling of the design of a humanoid robot since you indicated at the beginning, 800, 900 BC. So it's about 3 millennia now, we still don't have it. You study a lot of history. When will we have it?
When? I don't know. So it's very difficult to estimate the future technologies. That's correct. So the important thing that how to realize the imagination to real. So the ancient Greek, that is only the imagination. But now recent technology approach to realize such things to real. So now we are now in the stage, so then the middle. But most of the technology already developed because there is many artificial organs, right? So artificial leg or prosthesis. And we saw the Olympic game, and there is some prosthesis, but it makes run more faster than human. That means that artificial organs, artificial legs, artificial arms, everything, that is a kind of robot technologies. It approaches to the imagination to real. But about the AI, artificial intelligence, it means the brain, it's very difficult. So then already the other professors stated that the AI, the problem, the rest of the technology of the AI. So anyway, I believe that near future, I cannot identify who is a robot in this group. At that time, it realized the imagination to real. It's 20 years or 50 years, I don't know. But probably its time is approaching. So during these 20 or 30 years, it is very difficult to realize that things. However, first I mentioned that thinking robot is pleasure and fun. Then we can realize the final goal that ancient Greek people imagined at that time. Okay? That is my question.
Thank you.
Answer.
Let's give an applause to Shigeki and to all the speakers.